Little Josh said good morning to everyone.
Good morning, Josh. We miss you. Of course. Every day. We just be missing.
I wonder if he knows that there's a new school policy that if you miss an exam, you get 0 no matter what the reason is. I wonder if he knows that or not.
I was late.
You guys don't say anything to him, okay? We'll keep it a secret.
Yeah. I slept in yesterday, which is the second time I've done it this year.
Lucky for you, that policy kicked in today. Well, that was serious. Okay. So this next section is derivatives of trig functions. We'll do a little bit of other trig review first. A sector is determined by two radii and a sector angle. The area of a sector can be determined by using a proportion. So the ratio of the area of a sector, which is like a piece of pie, it's a portion of the entire circle. So the ratio of the area of the sector over the area of the circle will be equal to the ratio of the sector angle over a full turn angle. Now, a full turn angle is 360 degrees or 2 pi radians. So if we use this relationship, we can have our area of our sector over the area of a circle. We know the formula for area of a circle is pi r squared, and that will equal theta, which is the sector angle, over a full turn angle, which is 2 pi. And then if you multiply both sides by pi r squared, you'll get the sector area by itself, and it'll be pi r squared over 2. If you multiply this right side by pi r squared, then the pi will cancel, and you'll get theta times r squared over 2. So that's where that comes from. But remember from our arc length formula that A, the arc length, equals r theta, right? So if we replace theta with A over r, if we replace this theta here with A over r, then now the r's will cancel, and you'll get r times A over 2, or 1/2 A times r. So that's where that relationship comes from. So we can calculate the area of a sector having a sector angle of 2 radians if the arc length is 3.5 centimeters. So in this case here, if we want to find the area, it's theta r squared over 2, or 1/2 A times r. So you have to look and see what you're given. In this case, you're given the arc length, but you're not given the radius. That's what we're going to have to figure what that is. But we are given the angle, the sector angle, which is 2 radians, right? So we will start with theta equals A over r. Theta is a central angle, which is 2 radians. A, the arc length, is 3.5. We want to find out what r is. So if you cross multiply, you'll get 2r equaling 3.5, and r, the radius, will be 3.5 over 2, which will be 1.75. So now we can find the area by using 1/2 A times r, because now we found the radius. So the area will be 1/2 A, the arc length, which is 3.5, times r, the radius, which will also, and that will be in centimeters, by the way. Put our units in there. And r is 1.75 centimeters. And when you multiply centimeters by centimeters, you'll get the 7 centimeters squared for area. So if we calculate the area by going 0.5 times 3.5 times 1.75 there's our answer, which we can write as an exact value, 3.0625. And that will be in centimeters squared. Okay, so there's a new relationship there that we hadn't talked about before, and that is that relationship between the proportion for the sector angle over the, or sector area, I should say, over the full circle area equaling the sector angle over the full turn angle. We've talked about the inverse of a function quite a bit, starting in 10C. Talked about it again in 20, and then in 30 as well. A function is a special relation where for every element of the domain, there's only one element of the range. In other words, no two ordered pair have the same x component. The vertical line test can be used to determine if a relation is a function. If there's at least one vertical line that intersects the graph in more than one point, then the relation is not a function. Some functions are one-to-one. This occurs if both the relation and its inverse are functions. The horizontal line test can be used to determine if a relation is one-to-one. The inverse of a function is determined by interchanging the elements of the domain and range. Thus, the domain of the function is equal to the range of the inverse and vice versa. The inverse of f is denoted by f to the negative 1, and their graphs are reflections about the line y equals x. So, that horizontal line test, that's used on the original function. If a graph passes the horizontal line test, its inverse will pass the vertical line test. So you can look at the original graph, and you can tell by looking at it whether or not it's a function, by seeing if that original graph would pass the vertical line test. You don't actually have to graph the inverse to see if it is a function. If the original function passes the horizontal line test, then the inverse will pass the vertical line test. So you don't have to actually graph the inverse to know whether it's a function or not. So we did work in 30-1 talking about the inverse, and it's found, remember, by interchanging x and y. That's your first step. And then we want to put it in its original form, which is in the form y equals. But our first step is interchange x and y, because the domain of the graph or the function equals the range of the inverse. The range of the function equals the domain of the inverse. Domain and ranges are interchanged, so x and y is interchanged. But again, we want to get it in its original format, which is y equals, so I'll multiply both sides by y minus 1, and you can multiply out the brackets if you want. Remember, we want to get y by itself, so we'll add x to both sides and then divide by x. So there's the equation of the inverse. The inverse is the opposite operations in the opposite order. If you look at the original function, you would put an input into that, meaning you'd sub a value in for x. First you subtract 1, then you go 1 divided by that. The inverse is the opposite operations in the opposite order. Instead of by going x minus 1, you're going to go 1 plus x. And instead of going 1 over that, you're going to go the 1 plus x over x. Okay? Now this could be simplified by dividing both terms on top by the x on the bottom. And so this makes it a little more clear that it's the opposite operations in the opposite order. Again, the original function, you would start by choosing a number for x, subtract by 1 first, and then divide. The opposite, you would divide first, and then you would add 1. Right? So inverse operations, inverse order. This next one wants to know if an inequality is a function. And we're going to see that inequalities are never functions. We can see what this inequality looks like by isolating the y term. So it's negative x plus 2 over on the other side, because you've got to subtract x from both sides. And then dividing both sides by negative 2. And you might remember when working with inequalities, when you multiply or divide by a negative number, the inequality reverses. So instead of greater than, it becomes less than. Dividing everything by 2, it'll be positive 1 over 2x. And then 2 divided by negative 2 is minus 1. So we can see what the graph of this looks like. It says y is less than 1/2 x minus 1. So the points that satisfy this inequality are all points that are below the line 1/2 x minus 1. We can graph 1/2 x minus 1 because it's in slope-intercept form. That's a line that has a y-intercept of -1 and a slope of 1/2. So you rise 1 and run 2. Rise 1 and run 2. You can also rise -1 and run -2. And when you're graphing this, because y has to be less than 1/2 x minus 1, we use a broken line for that. The broken line shows that the points on the line are not part of the relation. That's what the broken line tells us. A solid line would mean that it would be less than or equal to 1/2 x minus 1. This is just less than. And again, all values of y that are less than this relation are part of our solution. Any point below the line. And there are infinitely many points that will have the same x value, right? There's just 2 of them right there. So basically, any inequality will not be a function. Because there will always be infinitely many solutions for these. Okay? All right, we're going to stop there for today. So for question 1 and 2, you're going to draw graphs, and there's some graph paper here at the front if you need. And then you're going to do 3a through h and 4a through c. There's also a bunch of you that didn't hand in the review for the last 2 chapters, 2 exams, so you should probably be working on those to get those handed in. Okay?
Would you like to get you some graph paper?
Go ahead.
All my head just